Hello, everyone. This class format call or comment. Okay. Uh, in this section, you will study a form of mathematical proof, which is called mathematical induction. This one will prove the statement involving positive integer n. Okay. And this is important that you will see clearly for the logical need for these lessons. And again, this one will relate it more like a sequence series. Okay, and this is the one lesson will involve to the sum pad question, which is find out convergent divergent. That's together with the limit. Okay, and they need this one for this proof idea also. Okay, so first of all, we're gonna go for the proving. We're gonna learn the principle first. Okay, the principle of mathematical induction, that you need to be able to determine the statement P, like a statement P here, or statement P subscript K plus 1. This one, okay, I did not write down. K plus 1 to P sub PK. Okay, this is very basic. So we see first what it's about. Okay, so see the example here, first one. Find the statement P subscript K plus 1 for each given statement PK. Okay, you just substitute for where the K substitute with K plus 1. Like for example, question A, we work for question A first. Solution. Just say this one PK, correct? So we replace K with K plus 1. And S means like a sum, okay, like a series. Okay, so become K plus 1. This one K. So equal to K plus 1 and the whole thing power 2. And this one going to be K plus 1 and plus 1. Okay, the whole thing power 2. And this one over 4. And then you just simplify this one. Become K plus 1, the whole thing power 2. And time K plus 2. Whole thing power 2 and over 4. You can live in this way or you can expand, depend the question. But this case, we live in this way first. Okay, that's all you need to do. Okay, for the first one. So now we do the question B. Question B here, okay. B do the same way, replace K with subscript K plus 1. So S means sum K plus 1. B equal to 1 plus 5 plus 9 and so on, right? And then from this one, 4, right? So then you replace K here, A1, K here. So become K plus 1, minus 1. Okay, and then minus 3. Okay, and then plus, this one plus. Replace K with K plus 1. So we have 4, this one like this. So become K plus 1, minus 3, and close it. Okay, so now we, up to this one, we just simplify, that's all. 1 plus 5, plus 9, and plus 1 plus dot dot dot, and then simplify it. Okay, so this one this one become K, correct? So become 4K minus 3. Okay, so this one you can write a simple bracket, and this one gonna be what, 4K. This one gonna be 4K plus 4 minus 3. Okay, so then simplify, this one gonna be what, 1 plus 5 plus 9 plus dot dot dot, become 4K minus 3, and then this one going to be 4K plus 1. Okay, so that's all for this one. For when you sum it up for K subscript 1. We learn this one because when we do proof, when you prove the formula, we need some idea about this one. So you have to get used to first how to substitute K with a K plus 1. Okay, we talk about proof later, but now we learn this one first. So next example, right? So this one also, see question C. So you have become k plus 1, okay, and replace k with k plus 1 also, and plus 3 less than 3, and then you replace k with k plus 1, the whole thing power 2. Okay, so this is going to be k plus 4 less than 3 times k plus 1, the whole thing power 2. Okay, so you can leave this one in the way, it's okay, or you want to expand it, it's still okay. Expand this one up, okay. Oh, sorry, this one should be 5, right? Not 3. Okay, so you can expand this one if you want to. Depend, I said it depend each question. So this one, if we expand, this one going to be k squared plus 2k, right? And plus 1. And this one the 5. And all this one, we're going to prove it later is true. Okay, now we do last one. Question D. Again, replace k with a k plus 1. Okay, and then this one become k plus 1. Greater than equal, we're doing this one, okay? So become k plus 1. Replace k with k plus 1, so we have this and plus 1. So now simplify it. So k plus 1 greater than or equal to this one time, right? Become 2k plus 2 plus 1. So we have k plus 1 greater than or equal to 2k plus 3. Okay, so that's the answer. Oh, this one should be k power. I'm wrong here, sorry. This one should be power, not on the same line. This is the index. This is the index, okay? This is the index. So it should be k plus 1. K plus 1. Okay. Okay, so I think that's all. This is the answer. Then I leave in right now at right here and see you next class, and we're gonna go for the proof for next lesson. See you next time. Bye bye.